Okay, so we're starting off with probability, and we're looking at permutations. Permutations, the order matters here. In fact, the order is what we're talking about. So in the calculator, you can use the NPR button, but we're not going to. Okay, we're going to use the box method because I think it makes more sense and it's more visual. So believe it or not, we have 6 dogs here. Okay, and I'm going to ask you the question: in how many different ways can these dogs finish? So they're at the starting line, and bang, or the gun goes off, or the hare passes them, the traps are open. How many different ways is it possible for these to finish? So he could finish first, he could finish second, he could finish third, he could finish fourth, fifth and sixth. Or another way would be he could be first, he could be second, he could be third, he could be fourth, he could be fifth, he could be sixth. So how many different ways is it possible for those to finish? Okay, so what we do in this case is we draw 6 boxes. Why 6? Because we're asked how many different ways can these finish, so we have to look at 6 places. So ask yourself, let's say this is the first position. Okay, so how many options have I of a dog coming first? So we start here. Well, at this point, any one of them can come first. So I have 6 choices of who comes first. Now, in this instance, the dog can't be 2 places at once. So if he finishes it first, he can't finish second as well. So I had 6 choices of who finishes first. However, now one of them is gone. Okay, so let's pretend he's gone. Well, then I have only 5 choices of who finishes second. And let's presume he finished second, so he's gone. So now I have 4 choices, and you see what's happening here. 2 and 1. At the very end, we have 1 guy left. He's the only guy who can finish last. And what I do is I multiply these. Okay, and if I multiply all that together, it's 720. Okay, so there's 720 different ways of these dogs finishing in whatever order. Now let's just say I was interested in just how many different ways they can finish first, second and third. So now I'm not going as far as 6 places. I'm only interested in how many different ways they can finish first, second and third. Well, again, they're all equally likely to finish first, so it's 6 by 5 by 4, and that is 120. So there's 120 different ways of all these dogs finishing first, second or third in whatever different order. Okay, with this one up here, I can say that's 6 factorial, okay, which is 6 by 5 by 4 by 3 by 2 by 1, all the way down to 1. This one I can't. Okay. Right, so, and if I was to do it on the calculator, it would be 6p3. Okay, but again, we're not tending to use that. Okay, now we're going to put in some stipulations, right? So if you look at this guy here, well, he was on the juice. He is huge and muscly and quick. He's on the EPO. Okay, so I can guarantee you he's going to finish first. Alright, and this guy here, well, he is after getting really old, so he just looks a bit of a mess. So I can guarantee you he's going to finish last. Now, I'm going to ask you again, how many different ways can these dogs finish? Well, let's draw our 6 boxes. Again, I'm asking how many different ways can they finish from first to 6th place. Okay, now, in a question like this, where there's stipulations, I know he's going to finish first. I know he's going to finish last. I start with the things I know. So, I know he's going to finish first. So how many options of dogs have I to finish first? Yeah, only 1. And I know he's going to finish last. So again, 1. Now I've dealt with 2 dogs. So how many is left? 1, 2, 3, 4. So 4 of them can finish second. 3, 2, 1. And we multiply them together, which is 1 by 4 is 4. And 12, which is 24. Okay? Right. Now this guy, okay, another question. This guy, he is after finding out about his drug taking, and he has said, I'm kind of like Lance Armstrong, do you know what? I am going on the EPO as well. So now these 2 guys, Well, they're going to finish first and second, but I'm not sure what way. Okay, so I'm not quite sure what way they're going to finish, but I do know they're going to finish first and second. So he could be first and he could be second, or he could be first and he could be second. I know one of them is going to be first and one of them is going to be second. The poor creator here, he's just going to be last. So let's have, again, draw our boxes. And that's why I keep away from this P method, okay? Because if we can draw it out and draw our boxes, we can use, I'm going to use that word again, our intuition, and try and figure out what's happening. So now, we've two dogs here, and they're definitely going to finish first or second, but with whatever order I don't know. So have a think, how many choices have I of a dog to finish first? Well, two. One of those. Now, one of them is after finishing first. So how many choices have I for second? Again, one of them's gone. Let's just presume he won. So now I've only one choice of finishing second. Okay, one of those. Again, this guy, well, he's going to be last. And I'm after dealing now with 1, 2, 3 dogs, and I'm left with 3, 2, 1. So there is 6 ways of those dogs finishing in whatever order. Okay, right, nearly done. Let's look at, let's pretend, okay, that these were caught cheating and this guy is back to normal again. So we have 6 equally likely dogs to finish. Okay, so we're back to normal again, all equally likely to finish in whatever order. There's no guy on drugs, the old fella's after retiring, there's a new guy after coming in, a new dog, and he's pretty good. So we have 6 dogs. And I'm asking you, how many different ways can these dogs finish? 6. Okay. Okay, so second last one. We've our 6 dogs. They're equally likely to finish. However, a bit of a bromance has happened with these 2 dogs. And they have decided that they are going to stick together. So, if he finishes second, then he's going to finish first or third. He's going to stay with him. And if he finishes first, then he's going to finish second. Okay, so they're always going to be beside each other. Now, one of them obviously they can't finish at the same time. So if one of them finishes second, the other finishes third or first. Okay, they're going to stick together. Okay, how do we deal with this? Well, we're going to treat them as one. Okay, so we're going to say they're one dog for the meantime. Alright, so now instead of having 1, 2, 3, 4, 5, 6 dogs, we have 1, 2, 3, 4, 5 dogs. Hence 5 boxes. Okay, and we're going to look and we're going to say how many different ways can these dogs finish. Well, there is technically 5 dogs. 1, 2, 3, 4, 5. So it's 5 by 4 by 3 by 2 by 1, which really is 5 factorial, which is 20, 60, 20, I think. Okay, so that's fine if there was a stipulation that this guy is always going to finish behind this guy, or maybe this guy is always going to finish in front of this guy. But in this case, I haven't said who's going to come before the other. So what could happen is these guys will all finish in a set order, and this guy will come second and this guy could come third. But equally likely this guy could come third and this guy could come second. So there's 2 options here. So what we have to do here is we have to count how many guys are going to finish together. There's 2 of them, so we're going to multiply this by 2 factorial. Okay, now 2 factorial is just 2, so it's 240. Okay. Likewise, if I said actually these 3 guys have made a pact and they're going to finish together, well, again, I'll treat them as one. Okay. Now again, I haven't said in what order they're going to come in together. Okay. So these 3 can be in any order, but again, we treat them as one. So we have 1, 2, 3, 4 dogs. So again, 4 dogs, 4 boxes. Okay, so 4, 3, 2, 1, which is 4 factorial. But then we have 3 dogs finishing together, so I'll multiply that by 3 factorial. Now 4 factorial is that, 3 factorial is 3 by 2 by 1. Okay, so 24 is 4 factorial and 3 factorial is 6. Okay, and as far as I know, that is 144. So they could finish in 144 different ways. Okay. Very last one for permutations. Often, I just use dogs here, I suppose, to keep it practical, but often we could be asked how many different ways can a word be rewritten, or how many different orders can we put these letters into. If I said rearrange, how many different ways can the word or the letters in feathered be rearranged with no letter repeating itself? I will use my 6 boxes. Okay, and it'll be 6 by 5 by 4 by 3 by 2 by 1, because again I could use one of these letters, any one of these letters for the first letter, but once I'm after using one I can't use it again. If though I said I could repeat the letters, so I can use the letters as many times as I want, well then I'd have my 6 boxes. But we have to think of it differently now. I am allowed to repeat the letters. I'm allowed to use them again and again. So I have 6 choices for my first letter, but I also have 6 for my second and 6 for my third, because I'm allowed to use these letters again and again. Okay. Again, if I had to maybe keep 2 letters together, okay, I will have, well, 5, was it 1, 2, 3, 4, 5, 6 factorial, sorry. I'll have 6 factorial because there's 1, 2, 3, 4, 5, 6 letters, and I'll multiply that by 2 factorial because these can come in any order. Okay, again likewise, if it was 3 letters were coming together, it would be 5 factorial multiplied by 3 factorial. And again, they can put in stipulations, so they can say, let me think, we'll just go again. So 6, 4. They could say rearrange the letters, or how many different ways can the letters in feather be rearranged, but F has to come first and A has to come last. Well, again, we start with our stipulations. F has to come first, so I've only one choice there. A has to come last, so again I've only one choice there. But I have 1, 2, 3, 4, 5 choices for the rest. 3, 1. Okay, and we multiply. Okay, so again, you're going to be using a combination of factorials or these box methods. Okay, so hopefully that helped. Okay, thanks.